So I don't know, I guess many of you heard of what happened with that paper. So those who don't follow Hungarian academics, politics, which is quite probably impossible if you're studying or working at CU. So this talk was originally sent to the, how should I say, the celebration of science. There's such a thing at the Hungarian Academy of Science, which will happen in the 7th of November. And in the computational and social science part of it, the plan was I will talk about it, but there were some scandals and problems, and technically this talk got censored. Not because the quality is bad, I hope. The reason was that word, that gender. So the Hungarian government have some issues with the word gender, and probably they have some issues with CU, as we know. So somehow I couldn't do the talk. And that's why I got a lot of attention in the Hungarian media. So that's why we made this talk actually public today. Or usually it's just a talk for the department when I get feedback about my own research. So excuse me if there's something that you don't understand perfectly, feel free to ask. I try to make it as simple as possible. So this is the gender behavior in open source software development. And you are the first one who can hear it publicly in Hungary. And in November you can hear it in Hungarian if you want to, in a kind of a satellite event of this one. And if someone is interested more in this scandal, feel free to Google it or ask me. So this is a paper we are working on with Balázs, who is my supervisor. And let's start it. So the core issue is what we can start is that I think, as we all know, the ratio of women in tech is almost steadily like decreasing since the 80s. And it's created a lot of problems in the industry in general. Also, women have, mostly in all fields, but especially in technical fields, there's a high gender pay gap, especially in the case of computer programmers. So women in average earn like 28% less than men. And which creates a lot of problems in long term. And one of the big problems is that most women who work in technical fields are leaving their professions in the middle of their career. So like around 50% of the women leave their STEM-related job in 20 years, compared to other fields where it's much less. And if we think about it as a society, we have a really high investment into these people who are learning technological fields, they are learning coding, and we lose all these women. What is the reason behind it, and why is it a problem? In the recent years, I think all of us heard a lot of scandals from the tech industry, especially from the Silicon Valley. The first one was the Uber scandal, where was this sexual harassment investigation. So more than 20 people get fired in the end, and it started like a huge series of scandals. It ended up in last year, all these scandals, which was like more revealed by women working in the tech industry, actually ended up in a book called Brotopia, which summarized this cultural problem which is happening in the Silicon Valley, that most of the culture is super male-driven and women feel excluded from this field, and how this is turning women leaving the industry and feeling non-welcomed. Also, other scandals happened the last few years. One of them was that actually Google got sued by 3 female developers who applied for a job as a backend developer, and Google is quite well known of that they pay way more for backend developers than front-end developers. And at the same time, guys applied for the same job with the same knowledge and experience, but the women are constantly get the front-end developer jobs, and in the long term they lost a lot of money. In the end, these ladies, by the way, lost the case, but it showed some problems what the industry is facing. And one of the most recent ones, you might have heard, it happened just like, I think last week, that Amazon was trying to automatize its recruiting process. So they build a machine learning model where they were having all of their candidate CVs who got into the company, and they try to build a model which will predict who are the superstars they need to in the end hire. And what it turned out, actually, this new AI tool was really discriminative against women. It was also a sample bias, but also if you were a woman, you were more likely to be not successful in this company. They just revealed this recently. So all this creates a big problem, and what we are in this research are trying to understand that all these behavior preconceptions are based on what we think about someone as a woman or a man, or there's any underlying mechanism within our behavior. So the main question is, are women at a disadvantage of who they are? Like, I am a woman who is in computer science, I am disadvantaged because I'm a woman, or because what I do? Is there anything that through socialization, all the culture of this industry drives me to be a little bit different and other people actually see that? So the empirical basis of this study is GitHub. Who is familiar with GitHub? So basically everybody, so I don't have to super explain what it is, but in a nutshell, it's like a Git repository system where everybody is pushing their codes. You can have collaborations, people create open source software together. We have a really huge data set of like 7 years of activity through the GitHub API, almost 8 million users, and we collected a lot of events of collaborations and user information, such as like creating a repository. This is where you put your code. When people push into a repository, opening, closing, and merging a pull request. Pull request is the act when you are collaborating with someone. If you are trying to have a code into someone else's repository, or if you are working with a company, but we only have the public one. So if you are trying to push into someone's code, or you are working together, you send a request, and the owner of this repository can decide if your code is good enough or not. And also we have user informations such as the nickname of the user, in cases when they gave the name, the email address, who they are following or who are following them. There's some social networking features here as well. And the number of stars, which is kind of, we could say that the community recognition. If I create something good, my repository can get stars. So this is basically how a profile looks like. You can see that there's the username. She didn't give her real name, but it's kind of her username. We have the number of repositories. We call the stars later the success of this person, because we say that the community recognition can be called as the success of the person within this community. The followers, here you can see their name, the following, that who they are following, and all the different programming languages what this person was using. It's also accessible through their profile. And this timeline shows here their recent activity. And since, as I mentioned in the beginning, that the dropping out from tech, it's a really big problem, we also try to capture how is the survival of these people. Does it depending on their gender or on their behavior? So what we call survivor, we have this data until 2016, I think September or October, and a year later we check again whether this person is still active or not. So we use all the data from the past to see that will they be active or not. So we call them survived if they will be active. So it's great. Nice.
You're showing the system.
Cool. So that's the question we are trying to answer. This is the profile of the user. So what we did, we tried to capture the genderness of the behavior. What is the genderness of the behavior? What we call the genderness of the behavior, there's a lot of different behavioral traits. What depends on our gender, and it's, so for example, if you are a woman leader, you are more likely to, and you want to be successful, you are more likely to behave more male-like in many cases. Or if you are in the other way around, you are more favored. If you are in a more female-like environment, you are more favored to behave as a woman. So what we do here, we infer everybody's gender based on their profile. If their name is available, we use their name and get their first name, or if their email address is available or their nickname, we are trying to infer their gender based on their name. Everybody got a gender, which it can be male, female or unknown. Most people are unknown. Around like 6 million people has zero information about their gender, or it's really hard to decide, such as name like Andrea. Andrea in Hungary would be a woman, but in Italy would be a man. So these people will be unknowns because we don't know that. And we don't use the picture of the people. We only use this information about who they are. We also do the same with the followers, with the people they are following, whether they are men, women, or unknown gender. And when we are to capture the gender behavior, we build a machine learning model to predict, based on all these different variables, whether they are women or men. Like, we try to predict whether they are women. So what are these variables? So we take in consideration their specialization. We have information about the different languages, what they use, and we create like factors of this, like whether they work in front end or iOS, back-end development, data science, or so on. We also take into account their activity, like the number of pushes, and a lot of like gender-related things, such as the number of female collaborators they have, the number of male collaborators, and also the gender of the people they follow. We only use variables what the user can actually control. So the people who follow me, it doesn't matter in this prediction because it's not my decision. What matters is like I decide I want to follow this woman or not. What our model shows is that this is the variable importance, and this is like the odds ratio. So the more red ones are more female-like behaviors, the blue ones are more male-like behaviors, and this is like the importance. So as you can see, that female homophily, which is like I work with women if I'm a woman, is one of the most important factors to predict I am a woman. And it's really likely for women, obviously. Also, front-end development is slightly more female-like behavior, and Drupal back-end as well, even though the stereotype would say back-end development is not something which would go to it's super female-like. The case of Ruby is really interesting because in the last 10 years there was a movement of like teaching girls to code in different languages, and one of the first one was the Ruby on Rails. You might have heard like Django girls, it's a really similar thing. Ruby on Rails was teaching Ruby-based development for girls, and there's a lot of beginner girls using these tutorials, and this school only accepts girls, and that's why it turned out to be a predictor of more like for women, because there is a little bit of bias of that. Also, what you can see, the number of females you follow, it's also more like a female-like behavior. So we use this prediction, and we call it femaleness in our models when we are trying to explain, does my gender or the gendered behavior, such as femaleness, is the thing which predicts that I will be successful or not. Okay, so this shows the result of the prediction. So here you can see that if you see the distribution of femaleness by gender, the blue one, I don't know how visible it is, the blue one are the men, the red one are the women, and the unknowns are, so the unknowns are kind of shifted to the right, so we can assume that actually the gender behavior says that probably more women are hiding their gender or are not giving that much information about their profiles, so they are, based on their behavior, they are more female-like. So we used different models to understand that is success and survival. So here you can see a lot of different models about predicting success, and here's survival. And all of the models have like, the first one is only taking into account that you are a woman and a lot of controls. And they're more significant, obviously, if they are further from this, let's say like 0. So this is positive, this is negative. So itself, the categorical gender, and then we have the gender behavior when we are checking femaleness, and we also included a measurement about like your name. So, for example, my name is Orsi. In an American setting, my name Orsi won't be obvious that I am a woman. So even if someone is like the categorical gender itself, it's not always straightforward, because if my name is not really well known enough to be a woman's name, if there is a if there is a just gender-based discrimination, it won't be obvious because no one knows my name is a woman or a man if I have a pixel picture and nothing of me. So these are the three main models I want to focus on. And one more. So the categorical gender itself is actually, if you see here, it's not really significant. So itself, just the gender, like being a woman, it's not a disadvantage just because being the woman. But if we introduce the name, it has a little bit of effect. So women with more frequent names are less successful. But the most important thing is that femaleness is the most important variable which actually predicts the success. It has a really negative effect in all of the different models. So let's see it a little bit more visual. So if we look at the predicted success of men and women, they are really close to each other, but here is femaleness. And as you see, femaleness, even for men, it has a negative effect. So if I'm a man developer who is working on a field which is highly female-like and my behavior is highly female-like, in that case, I work with women in front-end development, I will be also really unsuccessful. So not the gender itself, the thing that it generates which creates this disadvantage. And in the case of survival, there's not that much difference between men and women. Please note it's from 0.65 here, so that's why actually the difference is not that big. And here, the gender itself doesn't have a real effect. The femaleness is which has an effect to actually be more likely to drop out from the industry. And what's the case of those people who are trying to hide their gender? So let's imagine I'm a woman who is really scared to push any code on the internet and I don't put my name on, or I am a beginner and I just don't want to. It also have this negative effect. So whenever I'm trying to hide my gender, my behavior will tell who I am, or I will be also penalized for my behavior, whether I am showing my gender or I'm not showing my gender. So we also did a closer look on what's happening in the case of the future when actually more and more women are entering to this little world called GitHub. Here, the one which is like the straight line is the males and women who are started between 2013 and 14, so they are the older guys. And the other one is the ones who started between 2016 and 15 and 16. This effect is still there, so femaleness is also more penalized. So this is not changing by time. Okay, so what we can learn about this, so the development is actually not a function of like who am I, it's more like what am I doing. So it's a function of the gender behavior. That's an interesting question, that what we see here, that if we just push more women into the system, like, okay, let's have more women who are doing coding, but we have an underlying behavior, like as a woman, I feel better if I work with other women and I don't have access to, for example, management, and I close myself into these little cohesive, homogeneous groups working with people who are also in less prestige. It's not going to solve the problem. So if there is this, there's a big debate about like we want to have quotas about having more women in tech. If we don't do anything about inclusion, so if we are not trying to resolve the problem of these little groups when people are working with each other who are similar, it's not going to solve the problem. So we will have these isolated little islands within this company, and it's not going to help later on, and it will derive to dropping out more likely. Also, what we saw that hiding our gender is not beneficial if we have a so-called gendered behavior pattern. So our identity is still visible. And it's a question what I was thinking that there's this, let's have more and more women in coding schools. Should we rethink it? Is it beneficially long term because we are putting a lot of women in already on those fields which is already less prestigious in, for example, front-end development? Or we can think about it that it helps in the long term because it helps people to have like more confident when you are a beginner. It's just a question what people who are dealing with this kind of stuff can think about it. And that's it. Thank you.